All right. So
Yes,
shall
cukup
we
jelas
move
Evan.
on? Okay. I hope my voice is clear. Sometimes the network has. I hope you are okay. Okay. I just move on. Just a moment. Let me make this full page. Okay. So this is an example of CNC milling machine. We are focusing mostly on the milling part. Well, when you talk about milling, you can also do drilling on this machine. And later on, we'll look at lathe as well. Lathe is a thinning process. But this is the CNC milling machines. You can see an example here. In our school, we have this one, which is a machine from Germany. This is a five axis. Five axis, what does it mean? We will go through this later on. How can you tell if a machine is three axis, five axis, three and a half axis? If you talk to people from the industry, sometimes they say the machine is three and a half axis. What does it mean? Yeah, or if you happen here and you want to buy a CNC machine, the supplier will tell you, okay, this one has four axis or three plus two. So what all those mean? I will go through those later on because you need to understand actually what people are referring to when they talk about it. Okay, so this is one five axis like what we have in our school. If you go down to the lab, we have one of these controlled by actually it is handled by Encik Faris, our technical. Uh, this is a close look at the machining process. So you can see that this is the tool holder, okay, and this is the tool, the cutting tool, and this is the workpiece, okay. This is the table here down here, and below the workpiece you can see this is the fixture. Fixture is used to actually fix the workpiece so it won't move during machining process. I mean, it wouldn't move left and right on the table. So in the machining process, we have also here the coolant. This is the coolant that will deliver some coolant liquid to cool down the machine. Sometimes it gets very uh, heated up, and then the temperature will rise, which is not good. Okay, you can damage the tool, or actually the cut may not be accurate because we know that when the temperature rises, material will expand or some material metal will become softer. They will soften at higher or elevated temperature. So we don't want that to happen. So we use coolant. So this is a general picture of how a machining takes place. So in this case, actually what happened is that this tool holder, or this is the turret, we call this turret, or spindle. Okay, sorry, this is a spindle. This spindle will not move left and right, but it will just rotate, and then it will cause the tool to rotate as well. So how does it cut from left to right? What is moving here is the table. The table will move to the left or to the right. And then as it does that, this cutting tool will cut through. So that's how you do the cutting. Now you need to understand this in mind at the moment that the tool is stationary. It is just rotating, that's all. What is moving is the table. So keep that in mind because later on we will come back to that for you to understand another concept and be able to understand how you want to write the program. Okay. And on this left, right hand side here, this is also another milling machine. This is a very simple one. It doesn't have this all this enclosure and all these things. This is a very simple milling machine. Most likely this is just only three axes. We have X movement, Y, and the Z. So this most likely is only three axis. And here you can see this is a motor here. So this motor will actually transmit the power to the spindle to cause it to rotate at certain speed or certain RPM. And this rotation will cause the cutting tool to rotate and do the cutting later on. Okay. So this is the table. Okay. And at the end here, you can see this is this is also a motor. Actually, will rotate and cause the screw under the table to rotate. They will move the table left and right. Here also you can see that there is another motor here. This will help move it in this direction. So the rotation of motor will cause the screw to rotate, and then that's how the table will be controlled. Okay, how the movement of the table will be controlled by controlling the motor. Okay, and this motor are controlled by some kind of electronic system, from the program that you input here. So here the keypad, yeah, and the display. Okay, the same way here for this machine, you have the keypad here, the many functions here, the different thing, and this is the display here. So the program will be called from here. Then you can actually execute it. So it will do the control the motor, send the signal, move the table, and then you can do the cutting from here. So that's how basically a CNC works. And at the end of this table, actually there are also for modern machines, some of them they have some encoder or sensor. What does these two things do? Encoder and or sensor will determine the position of the table, and then will feedback the position to the system so that you can control the position very accurately. In fact, CNC machine is very accurate. Okay, it can even go down to up to 1 micron resolution or 1 micron accurate in terms of positioning system. Electronically, it is very accurate. What limits it is just the hardware. Sometimes you have error in the screw. You know, when a screw is rotating, it depends on the thread. Okay, if the thread is not accurate, and then each rotation, actually you will introduce some error, and this error will cause the movement not to be very accurate, even though electron to like 1 micron, 1 micrometer accuracy. So 1 micrometer is very, very small. Okay, so that's how CNC is, how accurate it can be. So this gives you a general idea what the CNC is. Okay, are you okay now? So boleh kan? Everybody can understand. Yeah. So this is the. Okay, I'll move on. Terminology actually these are just very straightforward. NC I just mentioned just now is numerical control. It is a method of controlling machine movement using letters and numbers. So remember these two words here, letters and numbers. These are important things because actually this will give you the idea how are we going to control that the machine later on. You have to have numbers and letters. A combination of both will actually give you the movement. Okay. And then we have computer numerical control, CNC. We add the C at the beginning of this, so a computer. So as I mentioned, when you have the computer capability, you can control the machine movement using coded instruction in the forms of letters and numbers, but with computer capability here. Okay, and right,